Hey, what's up everybody, and welcome back to another video. So in this video, you should prepare to level up, because in this video, we're going to go over one of the main things that separates a beginner Go developer from an experienced Go developer, and that is interfaces. So understanding interfaces is going to put you well above the competition when it comes to reading and writing code using the Go programming language. And after watching this video, I'm sure that you'll understand interfaces in the Go programming language. Just trust me. But before we get into the explanation, for those of you that are interested in becoming an indispensable member of a Golang team, I have a full course available on microservice architectures using the Go programming language, where we'll build out an entire microservice architecture. And following the completion of that course, you'll also get career coaching from me personally. So if that's something that you're interested in, the link will be in the description below. But without further ado, let's jump right into the explanation of interfaces.
Alright, so interfaces. So most people explain interfaces using polymorphism as an example, but I actually don't think that that's a good way to explain it, because you end up explaining polymorphism but not necessarily explaining interfaces. So I'm going to try and provide an easier way for you to understand interfaces. So let's imagine that we have an application here, and it doesn't matter what this application does or what it's for. All we need to know right now for this explanation is that this application needs to connect to some form of database. So if we have DB here, there are multiple different types of databases, right? So we have our standard like relational databases. So maybe we have like Postgres, MySQL, and we even have our NoSQL databases like MongoDB. And I think you get the point. Like, there are multiple different ways or different technologies that we can use to persist data, right? So if we're structuring our application in a way that's modular, and we're separating the responsibilities of our application into individual components, it would make sense that the database logic would be abstracted away from the application logic. So instead of building all of this database logic into the application, like tightly coupling it with the application, we can have our application provide some interface. Now, I'm going to start using the word interface, but I'm going to explain to you what it is. So let's imagine this is our interface. Now, let's take a second to think about what an interface is. Like, what is an interface? Just outside of the context of programming, what is an interface? Like, the dictionary definition of an interface is a point where two systems, subjects, organizations, etc. meet and interact. So it's a point where two things, the application and the database implementation, interact, like meet and interact. So if we think about it from a physical perspective, I just want to use an example here because this is like the simplest way to understand what an interface is. So there's a thing called an audio interface, and it looks like this. And this is a piece of hardware. And this hardware allows for the input and output of audio signals to and from a host computer or recording device. Now, just bear with me. This sounds wild, but this is going to become clear soon. So let's imagine that our database is the recording device, and our application is the computer, and the audio interface is the interface here. So in order for us to be able to, for example, record sound from the audio device and send that signal to our computer, we need to be able to plug into the interface, right? And that interface in turn plugs into the computer. And that means that we can send the sound from our audio device to our computer. In order for this to work, the audio device has to have a plug that conforms to the shape of the interface. So that is, the audio interface has these ports, right? And they have a specific shape to them. And only plugs that can fit into that shape can interface with our audio interface. So that means that the audio devices need to conform to the contract of the interface. Now, the same concept applies in programming, but in programming, it's a bit more difficult to grasp because we're not talking about like physical objects. We're talking about like virtual things, but it's the same concept. So what does that mean? That means that our DB implementations, they need to implement our interface. That is, their plugs need to be shaped such that they can fit into our interface or fit into our port. So in code or in the virtual world, what that might look like is this interface maybe defines some methods that need to be implemented. So maybe we need a close method to close the database, and maybe a select user method to select a user. So we can imagine this is our interface definition, which is essentially the same thing in the physical world as the shape of the port where we want to plug into, right? So this is defining the shape of the port. So if all of these different database solutions provide the implementation details for closing their connection and for selecting a user from their tables, then that means that their plug is the same shape as the port provided by the interface. Like these are conforming to the interface, so we can plug into the interface using either one of these. And from the application perspective, the application doesn't need to know the implementation details. Like the application doesn't need to know how Postgres is implementing the close method or the select user method, because from the application perspective, all it cares about is whether or not it can call this close method and whether or not it can call this select user method. And the interface is going to have like the function signature definition as well. So select user is probably going to need a user ID passed in as a parameter, right? So that means that the interface will have that in its definition. So I don't have space, so I'll just put here that user ID is a parameter. So that means that all of these different database solutions, they need to provide the implementation for a method where you can select a user using user ID. And this is how these different database solutions can plug into our application. So the interface is exactly that. If you want to think about it from a physical standpoint, it's a port, the same as with the audio interface. So it's like a shape. And in order for one of these database solutions to plug into our interface, it needs to conform to the shape of the port, right? The plug needs to conform to the shape of the port. And the way that it does that is by implementing the interface or conforming to the contract of this interface. And that opens up a number of opportunities for us. So that means that we could do different things. Like maybe there's some business need to swap out one database solution for another one. Since the application doesn't care about the implementation details of the database, as long as the new database that we're replacing the old one with implements this interface, from the application's perspective, it can still call close and select user. So it doesn't care whether or not the database solution changed. So you could think about it like this, like maybe in the application code, we'll close the database or something, or we'll select user in the code. And let's imagine originally we're using a NoSQL DB MongoDB. And in the application code, we're selecting user using this method, right? But then one day some business need arises and we need to swap out this database for, I don't know, MySQL. So this guy needs to move and we replace it with this MySQL. Now from the application perspective, MySQL implements this interface. Like it has the plug. So from the perspective of the application, it can still call close and select user, and it doesn't need to change anything, right? Because this database solution implements this interface, so it provides close and select user. So its plug matches the shape of the port of the interface. So this interface is providing a layer of abstraction. So all of this stuff here is abstract. That is, the application doesn't need to know about any of the details happening in here. It just needs to know that it has these two methods that are defined in its interface. And from there, the application is completely decoupled from the implementation details of the database solution. Now that is an interface. So with this understanding of an interface, now understanding things like polymorphism or different design patterns like abstract factory pattern, etc. becomes a lot easier because now you have a basic understanding of what an interface is. So now let's get into a quick coding example. Alright, so with our newfound understanding of interfaces, let's go ahead and quickly write up the code for the application from the example. So I already have a module set up here. So in this directory, I'm just going to create a new file and it's just going to be the main.go file. And this is where we're going to put the application code. And the package should be main here. And we're basically just going to do exactly what I mentioned in the video. So we're going to create the interface, and that's going to be the connection point for the database and the application essentially. So just bear with me for a second, it'll become clear soon. So we'll just do type db contract,
and that's going to be the interface. And in order for the database implementation to be able to connect to our application, it's going to need to implement this interface, or it's going to need to conform to the shape of our interface. So we'll do close as one of the methods that needs to be implemented by the database implementation, and we'll do insert user, and it's going to need to take in a username, which is a string, as the parameter, and it's going to need to return an error. And lastly, we'll just do select single user, and that's going to be username as parameter as well, but this one's going to need to return the user and an error. So this is the contract that the database implementation needs to follow or conform to be able to plug into our application. So we'll just create a struct here for the application, and we're going to need to embed the DB into the struct, and the type for DB is going to be the DB contract. So this is how we're saying that the DB implementation needs to implement the interface. And again, it's going to become clear soon. So just give me a second. So we're going to go ahead and write the code for essentially creating a new application. So we'll do func new application is going to need to take in a DB. So we need to pass in the DB to be able to create the new application. And then we'll say it's going to be type DB contract, which says that the DB that we pass in here is going to need to implement this interface or conform to the contract. And what's going to be returned is a pointer to the application struct. And we're just going to return essentially an instance of the application with the DB embedded. So when we create a new instance of this application, for lack of a better term, we're going to pass in the DB, which needs to conform to the contract. And then we're going to return the struct, or the new instance, with the DB that we pass in here embedded into the instance. And then from our main function, that's where we're going to actually create the application and stuff like that. So basically, we're going to first need to create the DB. So we'll do DB error equals, and we'll start with MySQL db.new. Now, as you can see, I already have this created here. And that's because I already created the two database implementations here. So we have a MySQL DB implementation and a Postgres DB implementation. The code's basically identical for both, just one's MySQL and one's Postgres. And in the implementation code, if you go down, you'll see that we can create a new DB using new here, this new function, and that's going to return a new MySQL DB. And all this code here is doing is just connecting to the MySQL database, and then it's going to return the MySQL DB. So what's important here actually is this struct here. This struct is actually the object essentially that's going to be returned from the call to this new function. So in main here, when we call MySQL db.new, it's going to return an instance essentially of the MySQL DB. So in main here, when we create this new one, we're going to get the DB back, which in this case is going to be the MySQL DB. So if we go back here, how do we know that this DB conforms to our contract from here? Like, how do we know that it's implementing these? Well, if you go back into the DB code here and we go down to under where we're creating this new DB, we have the function here for closing the DB, and this syntax here, in simple terms, is tying this function to this MySQL struct. And this MySQL struct is this struct up here. So if we create essentially an instance of this MySQL struct here, it's going to be associated with this close function here. And the same thing for this insert user function. Since we have this here in this syntax, it's going to associate this insert user function with this MySQL struct. And same thing for this select single user. This syntax here is associating this select single user function with this MySQL struct. So if you're coming from an object-oriented language, then essentially you can think of this as a class, this MySQL struct as a class, and you can think of this new function here as the constructor for the class. So to create a new instance of this class, then you would use this new function here, and you can think of these as the methods, the class methods. And the way that we're saying that this close method, quote unquote method, is a method of the MySQL class is by using this syntax here. Now, a lot of hardcore Go developers might have issue with me explaining it this way using OOP as an example. And they might even have an issue with me using this here for the receiver variable. And to be honest, I don't care. Like, go make your own video. But anyways, this is how I'm explaining it because this is the best way to explain it so that it's easily understandable. If you want to think about it from an OOP perspective, and if you don't want to think about it in terms of OOP, you can just understand that if we use this syntax here, we're associating this function with this MySQL struct by using this syntax. So that means that this MySQL struct is actually implementing the interface here because we have the close, the insert user, and the select single user functions defined, the implementation for those functions defined here. And this is how we're associating those functions with this MySQL struct. So if you see DB contract here, when we create a new application, we expect type DB contract. So that means that we can pass in that MySQL struct because it implements those functions described or explained in this contract here. So what do I mean by that? So what I mean is here, we can create this MySQL new, and the resulting DB that we get, we can pass it in when we create new application. Because if you go here, new application takes in type DB contract, or it takes in this interface here. And the MySQL struct implements that interface. So all of that to say that if you remember from the explanation, I had the diagram with the application, and the application needs to connect to a database. Well, here, this is where we're instantiating that application. So app equals new application, and we're connecting the database here. When we pass in this DB as the parameter, you can look at this as plugging in the database to the application. At this point, we're plugging the database to the application because this is where the interface or the connection point is. So we have a DB here and we have an application here, and we're connecting them both here when we pass in the DB here. And the reason we're able to pass in the DB here is because it conforms to our interface. So for example, if we were to just do something equals and then just put string here, and then we try to pass something in here, then of course it's not going to work because as you can see down here, it says that we cannot use something because it doesn't implement the DB contract. And it goes on into further detail saying that some methods are missing, like the close method, etc. So anyways, back to this, we can put the DB back there. So if we go back to the code for new here, we need to pass in the DB user, DB password, DB host, port, and DB name. So let's just go back to main here, and we'll just go ahead and create all of those variables as well. And of course, these are just dummy values for now. And then we'll just go ahead and pass those in. And of course, we need to check if the error not nil. And in that case, we'll do log.fatal because we need the DB connection for the application. And let me just minimize this. And since we created that close function, we can do db.close, or since we implemented the close function, we can actually defer db.close. And if we go to the definition of that, you see it's this close function that we created or implemented inside of the MySQL DB implementation. So back in main, we're going to defer the closure of the DB, and we can delete that. And now we can actually write some application code that's going to make use of the DB. So the same way that we associated functions with the MySQL DB struct, we're going to do the same thing for this application struct. So we'll do func, and then we'll do this, and it's going to be the application, and we'll create a function called run, and you can just imagine this is the application code or whatever. So we'll do username equals user1, and we'll do error equals. So now we can access the database. We can do this dot db. And that's because, remember, when we create this application, when we create an instance of this application down here, we're passing in the DB, which is then embedded into the struct here. And we can now access this property using this variable here, the receiver variable here. So we can do this dot db dot insert user, and we can just pass in the username. And if error not equal nil, we'll just log dot print error. And we can also call the other function. So we'll do error equals this dot db dot select single user, and we pass in the username as well here, and we'll just copy the error handling here, And now we have the user at this point. If we were able to get the user here, and we could just print that user. So this is just like some sample code for running the application. So if we go back down to the bottom of the main here, so now we have the app, so we can just do app.run. Now I'm going to make this a bit smaller so I can explain. So like I mentioned before, this is the connection point. Like this is where we're connecting the DB implementation with our application via our interface. So if you want to imagine it the same way from a physical perspective, when I talked about the audio interface and like the plugging into this new application, you can think of this part as like the port where you're plugging in the plug. Now, like explained before, one of the benefits of this is that we could swap out the database, because as long as it conforms to the interface, then we can use whatever database, right? So here I created this MySQL DB and this Postgres DB. So we could actually just change this here. So if you go up here, you see that I'm importing the MySQL DB right now, but I can also import the Postgres one. And back down here, instead of doing mysql.new, I can just do postgresdb.new. And as you can see, everything still works exactly the same. Like if you go to this run here, we don't need to change anything in run, even though we swapped out the databases, because all run cares about is being able to call insert user and select user. It doesn't care about the underlying implementation. So as long as whatever database you write the code for here, the implementation that you write the code for here conforms to our interface here, then we could swap it out or connect it to this application, and we won't need to make any changes to the application at all. And that's basically it. Like that's how interfaces work in Go. And I think that if you can understand interfaces, you'll become one step closer to being a much more advanced Golang developer. But anyways, that's going to be it for this explanation. If this video was helpful for you, please don't forget to leave a like. And if you're not already subscribed, go ahead and subscribe. I make a lot of videos explaining intermediate and advanced concepts in Go. And I also make videos explaining algorithms and data structures and other computer science topics. So if that's something that you're interested in, go ahead and subscribe. And if you're interested in enrolling in my course on microservices using the Go programming language, the link is in the description below. And with that being said, I'll see you in the next one.